Hello once again. We're coming to you from our offices in the downtown core, and we have some form of celebration going on here. Let's begin. This is presentation 5.1. We're talking about random variables. We want to discuss particularly the mean or expected value and the standard deviation in a random variable. Now we're going to suggest that we've already been talking about random variable. This was discussed in presentation 2.2, and where we talked about the number of sales by used car salesmen, perhaps in a weekly period. We have here the number of sales per week, and on the right column of that we have the probability of making this X number of sales per week. You can see it peaks at around 6. And this is a random variable X. Its outcome is determined strictly in random fashion due to chance alone. And we're talking about a relative frequency distribution here. And by looking at this, we can see that it peaks somewhere around 6. And this is called the expected value, or the mean of X. We write this symbolic with mu sub X equals 6. The number of sales per week less than or equal to 5. The probability of less than or equal to 5 sales per week, of course, is the sum of those. Now we're going to talk about the variability here. And this is much like the distributions we talked about earlier. And from here you can see that the variability, standard deviation, is around 1.5 cars per week. So the empirical rule suggests 60% of the time we can expect to sell between 6 plus or minus 1.5 cars per week. Now we're going to take this notion to the notion of playing a game of chance. We toss a fair coin 100 times. You receive 80 cents for each head, but you lose $1 if tails appear. And we're saying that 50% of the time, and remember 100 trials, so you're going to get 50 heads, 80 cents each, giving you a win of $40. On the other hand, 50 times out of the 100, you're going to lose $1, giving you a loss of $50. So the net loss, of course, is $10 over 100 trials, or 10 cents per trial. Now we're going to look at a systematic way of calculating this. We have a table here, and we'll be using this over the next week. We have here 100 trials, 50 each, heads and tails. And the loss and win is given here. This is the X. It's your P of X. And for various reasons, we're going to multiply these two numbers together. And of course, you recognize these two numbers here, what we calculated above. This is the expected values, of course, and the total of those is given on the screen here, minus 10 cents. So the formula for the mean expected value is given on the screen here, and there we have the result. And we're going to now look at the standard deviation. Here's the formula here, and note this expression here, x squared p of x, and we're going to suggest that that's this last column. X squared means this column 0.8 squared times 0.5. And here they come on the screen now. Add those up, and that is the expression here, 0.82, and this is the, of course, the expected value squared. This gives us 0.9, and that's a measure of the variability above the mean. So we can expect to lose 10 cents per trial, but this can vary by as much as 0.9 above the mean with a certain degree of reliability. And this, since it's not normal distribution, we have to use Chevyshev's result. Now we're going to look at the case of 3 coins. You receive $20 for 3 heads, $5 for 3 tails, but must pay $10 to play the game. Is this a good deal? So we set up the table. These are the events: 3 heads, probability coming up here, the win-loss, we received $20 but have to pay $10 to play. Net win is $10. $5, $10 to play, minus 5. Otherwise we lose $10. The probabilities are coming on the screen here. And you should feel free to pause the screen at any time and take notes. X times P of X, we're multiplying these two columns together. Here they come on the screen here. And this means we're going to lose, on average per game, $6.87.5. It's called mean or expected value. It's the expected loss on average per game over the long run. Standard deviation is given here again. You should write these formulas down. And we need this last column. Those values are coming on the screen here, which is x squared times p of x. Putting those in here, we get a standard deviation of 6.585. Now here's the distribution. You'll note that's very, very discrete. The height here is the probability. And you'll note that if we add these together, the total area probability is 1. The mean or expected value is on the quite negative here. And the standard deviation is plus or minus 6.585. And again, we'd have to use the Chebyshev result. And that's it, presentation 5.1. We ask you to take notes as required, and when you finish, go to presentation 5.2.